So, been doing some work recently with virtualization and watching all the fireflies. Lovely fireflies out today. And I want to talk about virtualization. A lot of people don't know the history of the computer stuff they're using, and so they get very confused. And so I've been trying to get Red Hat 9 up and working on this VirtualBox server that I have working on a big Xeon machine, and it's not working. It's kernel panic. And VirtualBox does a certain form of virtualization. And a lot of people don't realize this. There's three types of virtualization. Three. They were developed for completely different reasons, and they have different uses. And you can't just swap them in and out when you feel like it. It's not how it works. The hypervisor level virtualization, the bare metal stuff, has like VMware, Zen, KVM, those technologies. You're not running an OS. You're running a kernel that supports the bare minimum services to run virtualization. And then you run a VM, actually, a privileged VM, that runs that system. So that's how VMware ESX works, for example. That is entirely different from, say, VirtualBox or VMware Workstation, both of which use a host OS. They use the virtualization feature on the chip, right, which is built in. Usually it's a BIOS setting on a consumer grade machine. They're usually already set to use virtualization on a server grade machine. And then that just uses that hardware virtualization layer through the OS though, right? So the OS is still on top and using up resources. The hypervisor, that's less true. It's not entirely false, true because there's a kernel, but basically it's a different mode. And the hypervisor level stuff is supposed to be much quicker and have lower latency and better guaranteed times. And you can do different things with it. Some of those features leaked into the mid-tier VMware Workstation and VirtualBox type stuff. QMM is another example, right? Some of those features are there, but not all of them, and it's not the same, right? The OS can still interrupt. There's still issues. You can still crash things, right? And then there's containers. Containers are a type of virtualization. Containers are a very old technology, very old. Sun, late 90s, maybe mid 90s. The reason why Sun came up with containers is because Sun had very early on gone from 68,000 base, so-called CISC instruction sets, to RISC instruction sets, reduced instruction set computing. The reason why this is significant is because reduced instruction set computing allows you to do different things. So for example, when you have a RISC chip, your dies are very small. There aren't that many commands going on in the processor. It's reduced instruction set. And that makes for larger binaries that use up more memory, actually. And memory was fairly expensive, especially still back in the 90s. But Sun didn't care. They sold high-end machines. Their workstations were $15,000 to $30,000 or something insane, and their servers were big money. So because they had the same, they were a little bit behind in fab technology, but they had the same basic fab technology as everybody else. What they did was they made lots of cores, more RISC cores, more speed. This works great if you're supporting, multi-threading. But back then, multi-threading and use of multiple cores and all those technologies were brandy new. I remember setting up Beowulf clusters. I built one for a pharmaceutical lab that needed one. We used alphas because alpha is the best chip design ever by far. Anybody who tells you differently is wrong. Alpha was a perfect combination of CISC and RISC. Actually, they really had something there. So those technologies were using MPS 1.0 standards and things like that, which are multiprocessing standards. But you still have to write the code. And the code is non-trivial to write. Nowadays, GPUs do parallel instructions, right? This is more the stuff like SSE, right? Um, and AVX, those types of commands. Sun needed to have that stuff already, and what they did, because they had very high core count processors, very high back in the day, um, is they came up with containers. And what containers allow you to do is partition off, say, a core or two to run this thing. And then it looks like a virtual machine. But the key is in containers, you reuse OS components. So with QEMM or with VMware Workstation or VirtualBox, you create a virtual machine, you assign it processors and memory, and you give it a virtual disk, and then you load an OS onto it. With containers, you don't load an OS. It's already there. You're using the OS that you're running on. The OS is being partitioned out using various technologies that Sun pioneered, actually. I think almost all of them are Sun technologies, maybe all of them. And that's how containers work. Now, the reason why Java exists is because of Sun containers. Java runs in a container. Java, it's called the JVM, the Java Virtual Machine. You can run multiple JVMs on one machine. You don't load an OS into a JVM. The JVM is a self-contained unit. If you have several JVMs running and you do set the memory in the JVM settings with Tomcat or Jetty or whatever you're using, right? You do set the memory there. And when you set the memory there, it will only use that much memory for that container. When you make an OS call, it uses the OS's stuff already, it's usually already loaded in memory, and doesn't take up additional memory within the container. It takes up additional memory for the data transfer, but it doesn't load the additional libraries or IO stack or any of that stuff. It's got a hook back to the original IO stack. So if I take a server and I run VirtualBox and I run, say, 5 different machines, and I create 5 virtual NICs, I have 5 virtual NICs with full stacks, full code, full drivers, full everything. If I do that in 5 containers, I have 1 NIC and they all share code. All the 5 containers share the code with the 1 NIC that's physical. That's roughly how it works. I'm not trying to be precise and accurate on all the tech. It's boring, right? So because it shares the code, it's lower overhead. It's a lot quicker in some cases. In some cases, it's a lot slower because you've got blocking things and mutex problems and all sorts of other things. But generally, it's a lot quicker. And it takes up a lot fewer memory resources, which are very important to Sun because they've already ballooned the memory by making everything RISC. So they're trying to reduce the memory usage in containers. And then because they have containers, they've got Java. And that's where JVMs come from. It's that container technology. And then when that container technology becomes available on Intel, because Intel gets the wise idea to put in this virtualization stuff, which actually almost all of it works at the hardware layer. It doesn't have to. QEMM has a emulation modes, blah, blah, blah. It works on older hardware. But by and large, all the hardware has these, hypervisor sort of hardware built in allocation things at the hardware layer they get hooked into by the software. So that's where the virtualization comes from. Now, this is important because you wouldn't want to try and load an operating system in a container. I'm not saying that you can't do it technically or whatever. Don't care. The interesting thing is it's a bad use of the technology. It wasn't designed for that. This wasn't designed for that. It's also a bad use of technology to say reformat your laptop and load ESXi on it, and run VMware ESXi on your laptop. That's crazy. You can do it, but why? Right? You're better off running Windows or Linux or whatever on your laptop and using VirtualBox QEMM VMware Workstation. Then you can load as many other OSs as you want, run them simultaneously if you need to, whatever you need to do. That works just fine. So that is the correct engagement, we'll say, with that sort of thing. And it matters why these technologies came up and what the impetus behind them was. Intel enabling the virtualization stuff was huge in the industry. It just wasn't new. That Intel, as usual, was late to the party. Intel still makes the slowest and worst chips ever. For the longest time, AMD actually made faster chips. AMD still has faster 386s and 46s than Intel ever made. So yeah, they were never at the cutting edge of anything, unfortunately. And I heard a rumor, just a rumor, that when Intel bought the Alpha project from Digital Equipment Corporation, that the engineers scuttled it, so they couldn't use any of the tech. That's how much they hated Intel. That would have been the correct move for the universe, by the way, because screw Intel. Not a fan. Unfortunately, stuck with them. And, they make, for a while, we're making much better chips if you were doing floating point work, which I do, than AMD. So I haven't been running AMDs in years and years and years. And I do miss my AMDs dearly, but I don't think I'll go back. So it's important to know why these things work and how they work. And, little things like the Xeons on the server that I'm actually using, because it's a dual Xeon CPU. So it's got eight full cores, no hyper-threading. Xeons don't have hyper-threading. And there's a reason for that, right? They're much higher end chips with bigger caches and all kinds of crazy things. But there's also quirks to them and problems and whatnot. Look, it's important to know the history, because if you don't understand the different types of virtualization, then you'll use the wrong type or you'll do the wrong thing, and it gets very hard. That being said, how the hell did they break VirtualBox so that Red Hat 9 kernel panics on Windows 11 and on Linux, Ubuntu, but not on Windows 7? I don't know. It's a good question. The Windows 7 image works. I transported it to the Linux machine. It doesn't work. I have no idea what that could possibly be. I can't even fathom what this error is. It's very bizarre. I'm hoping I can figure it out. No one else seems to think it exists. So I don't know. Everybody knows it exists on Windows. For some reason, if you enable Hyper-V on Windows, it will do this to the Red Hat system, which just blows my mind. I don't think the people writing the code nowadays really understand how any of this stuff works. Otherwise, you would be able to transport a working VirtualBox VM image to another VirtualBox, and it would just work. Clearly, that is not the case. Why that is not the case, I don't know what they broke. They must have spent many man hours breaking this. But yeah, look, there's different types of virtualization. There's different ways to approach problems. They have their ups and downs, their pluses and minuses, their trade-offs. And it's good to think about that, especially in computing, because it's everywhere in tech. There's trade-offs everywhere in tech. There's usually trade-offs of things like amount of storage for amount of weight, how fast you want things to go versus how stable they are, right? And, is that 2% faster worth instability? These are good questions. I don't have answers to them. You have to answer them for yourself, for your own particular situation. I had to stop running containers on my Windows 11 machine because it would crash. That's right. The containers didn't have to be active. Just having Docker loaded and running would crash the laptop. So I don't run it anymore. Maybe it's gotten stable since the last set of Windows updates. I have no idea. But also Docker, and I'm not a super huge fan of containers to begin with. So certainly there's some use cases for them that they're excellent for, just none of the ones that I use. So yeah, that's worth kind of knowing. So just wanted to get that out of the way and give you, a little bit of context, at least for virtualization. If you like it, let me know. Maybe I'll do more. If you don't like it, let me know. Maybe I'll do less. And if you got topics or whatever things you want me to spout out about randomly, I may do that. Who knows? Depends how I feel. These are kind of random. But either way, let me know.